Hello students, in this question ABCD is a rectangle and PQRS are the midpoints of the sides AB, BC, CD and DA respectively. We need to prove that the quadrilateral PQRS thus formed will be a rhombus. Let's draw a diagram. ABCD is a rectangle. ABCD is a rectangle. It's here. ABCD is a rectangle. We need to take the midpoints of the sides. Midpoint of AB was P. It is given here. We need to take the midpoint P of the side AB. It is respectively. So it should be in the order. Point Q is the midpoint of BC, point R is the midpoint of DC, and S is the midpoint of AD. Let's join these points together. We join all these points. So a quadrilateral is formed. Now we have to prove that this quadrilateral PQRS is a rhombus. Well, to be a rhombus, it must be a parallelogram with all sides equal. A parallelogram with all sides equal. Will make it a rhombus. Right. So we have to work in this direction. Let's first prove this is a parallelogram. To prove it a parallelogram, we need to draw diagonal BD. Let's draw the BD. Diagonal BD. Okay. In triangle ABD. In triangle ABD, P and S are the midpoints of the two sides. P and S are the midpoints of the two sides. So according to the midpoint theorem, PS must be parallel to the third side DB, right? DB. Also, PS should be half of DB. This is the first thing we have found here. Another second thing is in triangle BCD. In triangle BCD, we have to do the same thing. Similarly, in triangle BCD, we can write QR is parallel to BD and QR is also half the length of BD. This is our second equation we can say. From these two equations, we see that the two opposite sides of the quadrilateral, means PS and QR, they are equal to each other. PS and QR are parallel to each other and equal to each other. From 1 and 2, see, PS is parallel to DB and QR also is parallel to BD or DB. So both the opposite sides PS and QR are the parallel to the same line. So they must be parallel. PS is parallel to QR. Also, we see that PS is equal to half of DB. QR also is half of DB. They are half of the same thing. PS and QR are the half of the same thing. So, we can write PS is equal to QR. Thus, PQRS is a parallelogram. Parallelogram. So first part is proved. Our aim was to prove PQRS as a parallelogram with all sides equal. We have proved it parallelogram. Now we have to focus on how to prove all sides equal. Well, the two opposite sides are equal. Now similarly, it can be proved that PQ is equal to SR, right? Because if we draw the second diagonal AC and use the midpoint theorem, PQ will be half of AC, SR will also be half of AC. So PQ and SR must be equal to each other, right? So what we see is they are equal to each other. Okay, so we have collected PQ equals SR and PS equals QR. Let's consider these two things. PQ equals SR is suppose our third equation, and PS equals QR is our fourth equation. Well, what else? We know that diagonals of a rectangle are equal. Diagonals of a rectangle are equal, right? Diagonals are equal. Okay, that means AB and AC and BD must be equal. AC is equal to BD, so their halves must be equal. Half of AC, let's write it in this way, half of AC must be equal to half of BD. We already have seen that half of BD is equal to QR, and half of AC will be equal to PQ, right? So let's mention it here. Half of AC is equal to PQ. Half of AC is equal to PQ. And let's make a change here. In this equation 3 and 4, we should mention here PQ equals half of AC, right? So this is our third equation. We don't need these two equations. Well, so half of AC is equal to PQ, and half of BD equals QR. PQ equals QR. So what we have proved here, that adjacent sides are equal. Opposite sides were already equal because we proved them. We proved both the opposite sides parallel and equal. That was a parallelogram. So opposite sides were already equal. Now we have proved that adjacent sides are also equal. Thus, we have proved all the four sides are equal. PQ equals QR equals RS equals SP. Right? All these four sides, PQ, QR, RS, SP, are equal to each other. So PQRS is a rhombus. So it's proved.